Hello, and welcome to Developer Days Day 2, IdentityNow, Transform and Rules. My name is Christian, and I'm a Principal Solution Architect at SailPoint. And Lex?
Hi everyone, this is Lax Venkatramaya. I'm a Senior Solution Architect at SailPoint and working primarily on IdentityNow implementations.
Okay, so I'll just kick off and cover the transform side. So we'll start going through with that. So first off, we need to see what an actual transform is. And in essence, it's just a function that takes input and transforms it or processes it and creates an output. So it can be used throughout IDN as a method of normalizing accounts and identity data. So as you know, IDN does aggregate lots of information from all its different sources and so on. And it may be the case of that when we need to actually represent that data in another system or on the identity cube itself, then we may need to do a transform on that, maybe to lowercase emails so they're all normalized, or some other effect. Another way that you can think of what a transform is exactly, it's just a JSON object. And you can load the JSON object up into IdentityNow just via REST API. So as an example of a transform, we're going to take the input foo with an uppercase F, and we're going to push it through at the lower transform. So we've got lots of different types of transforms. So here we're showing what happens with the lower, and expectedly, the output will be foo, but it's in lowercase. Also, you can actually have multiple inputs on for the actual transforms as well. So here we have a concat transform, and from a developer's point of view or programmer's point of view, a concat is a concatenation of a couple of values. And here we can see that we're concatenating foo and bar, and it will transform that into the output value foo bar. So if concat and just a few others were all that we had, it'd be a bit limited, but we have lots of types of transforms. And I'd recommend you going through all of them and understanding what they do. Because when you're actually building transforms, understanding what you can actually do as a whole will lead you to make a nice, concise and powerful transform objects. Just skipping through this, we're going to be looking at account attribute specifically, and we'll probably also be looking at static as well, static in particular, because you can do some pretty neat things with that, and some other bits and pieces as well. You don't immediately have to understand what the syntax of all these transforms are, because each of them are configured in different ways, but just know what they do and what you can do with them, then that's enough to kind of get you going. So one of the things is, I mentioned before that we can, a transform can have multiple values being pushed into it. You can also use the output result of one transform as an input for another. So here we're concatenating foo and bar again, and then we're applying a lower transform, and that will give us foo bar as a final string in lowercase. So if you think about that, and you can concatenate any one of those, you can nest any one of these transforms together in multiple nesting transforms, then you can get some pretty powerful combinations. So one of the things I said is that you've got each of these transforms can be configured to behave in different ways, and that's done via what's called an attribute map, or a map of attributes which determine its behavior. So each transform will have their own very specific configuration. So please read the information, the documentation on each transform to understand what those would be. So here we see that we've got a replace transform. And what we're doing here is we're looking for the string value of bar and transforming that to baz. So we're doing a replacement in the string. So similar to the previous example, we're going to be concatenating these two strings together. But on the way through, if the replacement transform sees bar, it will place it to baz, and then to lowercase, it will output foo baz in lowercase. So again, this is another way of showing that you got a nested transform, and you can mix them together to give a more powerful result. So there's three main components when you're thinking about configuring the transform. And as you can see on the screen, we've got a JSON object which actually represents this. So it needs a name, but only the top level or the root level transforms need an actual name. It needs a type, which specifies what type of transform we're going to be using for this, and attributes. So the attributes, as I said in the previous slide, are how you're actually going to configure this particular transform to do some work. So for a transform to work, it needs input. And we've got two different ways of inputting it. It's either going to be an implicit or an explicit input into the transform. So if an input transform attribute is not configured on the transform JSON, then the input is implicit. Likewise, if the input attribute is configured, then it's an explicit input. So let's say with an IdentityNow that we got source 1 and source 2, and I'll explain what these are. So source 1, we're saying that department field has the name services, and in source 2, the department field is set to engineering. So we look at the transform being used below, and we see that source is set to source 1, and the attribute is department, and the transform is lowercase department. So bear this in mind, source 1, services, source 2, engineering. So if we're implicit, then that means it will take the value which has been inputted from the UI, and it will transform that data. So here we're saying that source 1 department, so it will take the source 1 department, and it will output services in lowercase. So that's implicit. It just takes the value from the UI. We can also be explicit, and that's basically tell the transform what the input is for its usage. So here, again, we can see that in the UI, we're saying source 1, attribute, department, and we're using the lowercase department. But if you notice on our JSON, we have an input JSON object there, and it's saying to go to source 2 and get the department. And the resulting department value will be engineering in lowercase, which is actually from the source 2 source instead of the source 1, which is from the UI. So implicit takes the value from the UI. Explicit, you specifically tell it where the information is going to come from to drive the transform. So another aspect of transforms is that we have inbuilt a velocity template engine to help drive its value, and it can transform that. So if you go to the Apache Velocity website, there it gives you more details on actually how velocity works. It's quite powerful. It's a templating engine. and I'm mentioning here that it's usually used in the static transform type. So I'm giving you a quick example here, but I'm going to be talking a little bit more about that in a couple of exercises away. So there are two primary places where we actually use transforms. The identities on the identity profile. And those are used to calculate what the attribute values are, and it's usually refreshed on the identity refresh process. Also, we use them on accounts, normally used for creating new accounts on the account creation policy. So from usage from the identities, so here we're saying that we need to get in a way to test them and see how the values actually get transformed. You can configure on the identity profile and the actual transforms themselves, or you can upload them into IdentityNow via the REST API. So once they're there, you need to see how they actually perform. So to test them, you can go to the mappings on the identity profile and click preview. And there you can see what the actual value is after you've applied the transform. Once you're happy with that behavior, you can just update the profile, and which will kickstart the identity refresh process and refresh the identity attributes for that transform. If you're developing transforms, it's always good to do them in a lower environment, so you can practice and test to make sure that the results are what you expect. So on the account side, you can use transforms on a provisioning policy. I mentioned here the create profile. And so that's useful for doing default values and transforming information from the identity cube onto the actual account. You can upload them via the IdentityNow REST, via IdentityNow, the REST API or the UI. And in order to test it, you need to trigger a create profile or sorry, a create account via IDN, which could be just requesting some access or a role. Once you've done that, they automatically apply to all provisioning events as well. Again, I would test these in a lower environment. So I mentioned before about the static actual type. What this allows us to do is to configure a transform to result back a value which can be used for your other transforms. So transforms are the static ones are effectively a declaration of variables which can be used throughout the transform objects, and it uses velocity to discern its value. Here we can see that we got worker type set as the actual value, and that is the result of the account attribute transform being brought down. That name is then used statically, and it can be referenced with other transforms. So if you notice that the worker type, the string worker type value there is actually a velocity template. So we can actually look at this in a little bit more detail here. It's the same transform, but the value has changed, and we're augmenting it with a decision about what value you're going to return back. So we can see here that worker type, which is the value which is returned by the account attribute. If it's employee, we're going to return back a value of full time. Otherwise, we will return back a value of contingent. So again, using velocity, you can make some powerful decisions inside here and then reference them in your other transforms. So from a testing point of view, you can test transforms by going into the identity profile and click mappings. Choose a transform map and then preview it. Again, I'd do it in low environment, but that will give you the actual result of the actual transform on your data. So when you're testing transforms for account data, then you need to trigger and create process. And you can do that via an access request or an assignment of the new role. So on the development side, first of all, I'd get familiar with the V3 APIs. So the V3 transform APIs will allow you to update, create them, delete them, list them, and so on. So it's always useful to actually get familiar with that. Using curl or Postman or whatever tool that you use. I use Postman quite a lot and curl. And also, it's good to use an IDE. I stress use one with color coding because sometimes the transforms can get complicated. So having color coding allows you to easily and quickly see different sections and any kind of errors that you may have missed, like a curly bracket somewhere. Additionally, if you're using Velocity, there are some websites that you have Velocity Engine built online for you to use, where you can actually feed it values and you can see the results. So you can also test your velocity side basically on the web with very little tooling. So that's useful because you maybe have some complex velocity that you need to build to make your static transforms return back the value that you're looking for. So some of your best practices, you may end up with some complex transforms depending on your use cases. So I think it's probably a mixture of a couple of things. First of all, do understand what's available for you from the variable transform types, because there's usually more than one way to actually resolve this problem. And two, I would do it in bite-sized pieces. So solve each of the small problems on their own, and then bring them together as a whole. So from a best practices point of view, a good JSON editor, absolutely. Again, with color coding and so on. Microsoft Visual Studio Code, for instance, is very good. There may be a presentation either yesterday or there will be today on some things around that. But yeah, any editor. I've used Visual Studio Code and I use Notepad++ in the past as well. Now, leverage examples, because a lot of the time you're going to be trying to solve a problem that most likely has been already solved somewhere else. So have a look on Compass website. If you do something cool, then please share it. We'd be very, very interested in that. And actually getting feedback on it as well, where people may be able to help you, make it even more efficient or smaller or more readable, whatever. Share it with Compass. And you'll probably find the feedback most useful. Same problem, multiple solutions. So I mentioned that in the previous slide is, you need to be able to understand all the different transform types that we have, which can help make the solution as simple as possible. It's quite easy to pick the wrong transforms and end up with quite a complicated transform object. So understanding the best type to use is going to be the best, is a way to actually make it. And keeping your transforms as small and neat as possible means they're more maintainable. So the other thing about keeping transforms maintainable is avoid repetition. If you're copying and pasting, then I would suggest you use a reference transform instead, and use the transform that way. So if you've got something which you commonly use, take it out of your transforms and reference it with a reference transform instead. And that means that, you know, there's only one place to fix it for all the things which may be using that. If you find something which is unexpected, which leads me to my next point: bad data. So we only know what we know, and when data actually comes into into the transforms, you may be getting some information that you wasn't expecting, and you may have to go back and address that later on. But in which case, you should configure your transform so that if there's something unexpected happens, then it's handled in a way which is acceptable. And don't forget, what is the case today may be different tomorrow. So something may happen in a target system that may introduce bad data, which is unexpected at the time where you developed it. Okay. Lax, are you ready to quickly do a demonstration for me? I'm hoping Lax is there. Okay, it looks like we're getting a technical issue. So at this point, we'll be doing a demonstration for the transforms. So right. So Lax, do you want to do the?
Yeah. So is everyone able to hear me now?
Yes, I hear you.
Okay. Yeah. Thank you.
Welcome back.
Yeah. So yeah, let's quickly demonstrate some of the transforms. You know how easy we could build a transform, deploy the transform, and also do the validation, right? So for the transform, what we do is we use the API, the transform APIs. So those are available, those are published in our API documentation. Let me quickly bring up here. Okay, so if you go, it's V3, and we have transforms, right? So we have a list of APIs that's available. One is to list transforms, where we can list all the transforms that's available in the tenant, and then create transform, that is to create, update transform is to update, and delete transform is to delete. So let's quickly go through some of this API, and then I can demonstrate one simple transform. Okay, so like this list transform. So this is again, I'm connecting to my personal tenant. So with the list transform, I can view all the transforms that are available in the tenant, right? As you see, I have a bunch of transforms, like some demo, employee type, and demo, stuff like that. Okay, so let's quickly go and build one new transform. Okay, so this is one common use case, right? The calculating the display name, right? Typically, the use case would be, you know, they want to concatenate first name, last name, and preferred name to populate the display name, right? In our case, what I'm doing is I'm concatenating first name and last name. Okay, so in my case, the employees is the authoritative source. So what I do is I'm using one transform. As you see, it is of type account attribute. Okay, so I'm referencing the first name from the employee source. Okay, and then the last name from the employee source, and then I'm using this static transform where we are using the velocity code to concatenate, right? As you see, it is concatenation of the first name and last name. So let's go ahead and create this transform, right? For the create, we use this create transform API, and let's submit it, right? So I get the response 201. It means that the transform got created. Okay, so now I can go over here and I should be able to see it. Let me go ahead and refresh my screen. Okay, let's go to the display name. So as you see, the display name, I'm just mapping some static values, first name, but then let me go ahead and select the newly transform that I just deployed, right, which is a demo display name. And save the configuration changes. And then I can view, before I even apply the changes, I can view whether my transform logic is working as expected, right? In the identity profile, we can go to the preview, and then we can take a look at the data, right? So now I can confirm it is concatenating first name and last name, right? Once the value looks okay, then I can go in and publish changes. Okay, then the identity profile will be updated, and the whatever the configuration change that we made, that will be applied to all the users. So all the users will have a display name populated as a concatenation of first name and last name. Okay, with that, we can move on to the rules. So let me bring up the presentation for rules. Okay, so the rules, right? What is rule? The rules are essentially a code configuration, and they allow advanced logic and calculation, right? And the functionality in the SailPoint platform. And so these are essential something that we have inherited from IdentityIQ. Right. If you're familiar with IdentityIQ, that product is too much dependent on rules, right? And essentially, these rules read and write just like Java, right? But a lot of them use bin shell, and we also have a rules of other types. We can use other languages like a PowerShell, right? So these are primarily used for advanced logic and calculation of attributes, and they also can be used for functionality like connectors, and also define. It also depends where they execute, right? So the rules are very powerful because the IdentityNow architecture. We need to take some special considerations regarding the rules. So all the rules need to go through some kind of rule review process. Okay. As I said, the rules are broadly classified into two categories. One is the cloud execution rules. The other one is connector execution rules, right? It depending on the way the rules are executed. Some rules are executed on the IdentityNow cloud, and some are executed on the connector side, where they'll be executed on virtual appliance. Okay, and the example of the cloud the rules is the attribute generator rules, right? And so these the cloud rules will have access to the internal database of IdentityNow, right? And they have access to the internal data model in the cloud. So but and these cloud rules does not have any access to the source systems, right? They cannot talk to the virtual appliance, and as they are operating in the cloud. Okay, and so the connector rules are opposite. The connector rules do have access to the source system, and they can, but they do not have access to the data in the cloud, right? They don't have, yeah. So that's how they are structured. Okay. So now coming to the role implementation. There are certain ways we implement cloud rules, and there are certain ways we implement connector rules, right? So I want to talk about each of these use cases, like how each of these cloud rules are implemented and how connector rules are implemented. And also there is the third use case, how we are going to migrate rules from one tenant to the another tenant. So first, let's talk about the cloud rule implementation. So the cloud rules are tied to the cloud-based functionality. So these rules are embedded in the microservices, right, that live in the SaaS architecture. So the examples include the identity attribute calculation, right? As we saw, that typically the identity attribute will be defined on the identity profile, and sometimes if you're not able to achieve the desired results of the transform, then we need to implement this identity attribute rule, right? The other is account attribute calculation. So that would be typically during the provision of the target system, right? One example could be generation of the SAM account name during Active Directory provision, right? The other example is generation of the distinguished name during Active Directory account provision, something like that. The other examples of the cloud rules are the manager correlation, right? And account correlation. So these cloud rules are typically need to query the IdentityNow data model in order to complete the task, right? Access to any of these IdentityNow data is read-only, and we cannot make any calls outside of IdentityNow because they don't have access to the virtual appliance, right? Um, because they are executed on the cloud and they are embedded in the microservices, a code review is necessary, right, for the cloud rules. So the cloud rules are still required to go through the rule review process, but we have some automated validation and deployment process. We are actually looking at long-term ways to safeguard these without degrading the performance and breaking the functionality, right? And so we also have this IDN rule util wrapper built by our engineering team. So we encourage everyone to leverage those IDN rule util wrapper methods when we are writing, when we are querying some data from the IdentityNow data model. Okay, so as I mentioned, some of the supported cloud rules are identity attribute rule. One example is you know maybe generation of or if you have some complex logic for the display name calculation, right, which we cannot achieve through or for example the lifecycle state calculation, right? That would be good example because most of the provisioning use cases in IdentityNow, they are based on the lifecycle state, right? And the lifecycle state calculation depends on data from a lot of different data sets, right? It could be the hire date of an employee, the end date of an employee, and the status of an employee. Like that, we need to consider a lot of different attributes, right? Sometimes it becomes complex to achieve the desired result through the transform, right? So in those cases, we need to leverage identity attribute rule. And the account attribute generator, that's typically doing the provision. And the correlation, so out of the box we have this correlation config, right? But in some cases, let's say we are implementing a source and they have a requirement where you need to strip off some characters of the attribute of the target system and then correlate the value, right? Those we cannot perform through the correlation config. In those cases, we need to go with correlation rule. The same thing for manager, right? If there is no straightforward mapping between the target system and then the identity model, then we need to implement this manager rule, right? And the before provision rule, this is for some kind of complex use cases where if you need to modify some of the provisioning request before it goes to the provision engine, right? One example could be if you need to move an Active Directory account from one OU to another, right? During the termination flow, right? So we can achieve some of those through this before provision rule. And another is generic rule. Again, the generic rule can be used either in some other use cases, right? And the other is the integration rule, right? So if we have integration with systems like ITSM, right? The ServiceNow ITSM. So that's where we can implement an integration rule, and we can populate some of the attributes through the integration rule. Now, as I said, there is a review process. So let's talk about how that review process looks for the cloud rules. Okay, so the review process starts from submitting the request, where the request has to be submitted from the SailPoint side, and then and the request will be reviewed by the reviewer team, right? We have a team of reviewer team where they review the code and make sure there are no issues in the code, right? There is no infinite loop in the code, and the code is following the best practices and all those things, right? Once the review team approves the request, then it will be automatically deployed into the tenant. And the review team will update or confirm the rule has been deployed to the one who submitted the request, right? And in case of typically this the rule review request will be submitted by the SailPoint team, right? It could be a member from the professional team or member from support, right? So when it comes to the partner or customer, they cannot directly submit this review request. Instead, what they need to do is they need to submit the request through expert services ticket. Okay, and once they submit the expert services ticket, and that ticket will be picked by a member from the professional service team, and they will submit the rule review request on behalf of partner or customer, right? And the rest of the process will follow the same. And if there is any kind of feedback, if any changes are needed, then the expert services team will communicate back to the customer, and they can make the necessary changes, and resubmit the request. Okay, so now let's talk about the second use case, which is connector rule implementation. As I said, the connector rules are tied to the connector-based feature implementation. So what these rules are doing, right? They're altering or fetching additional data from the source system, right? And that may be changing some information, right? They may be doing some advanced provisioning type. Or they may be just an implementation of a generic connector like web services, right? Or it could be a database connector. So these connectors actually rely quite heavily on the rules, right? Because these generic connectors like database or web service, it doesn't come with the default provision, right? The connector only provides a template, but then we need to implement the provisioning, through the rules. And these rules are executed on the virtual appliance, so they don't execute on the cloud, right? And they don't have any access to the cloud data model. So because they execute on the virtual appliance, our engineering team has made some enhancements to the architecture, and so that the rules do not require rule review process, right? So our engineering team has published some APIs. So using the API, we can deploy the rules, these connector rules to the tenant, and we can update and then manage all the connector rules. Okay. And some of the examples of the connector rule include these, the delimited build map rule, right? So as part of these build map rules will be invoked during the aggregation flow, right? So when we are aggregating from the delimited data source, and if we need to modify some of the aggregation data, then we can leverage these bitmap rules. And so we have a connector before create, modify, and delete. These are mainly for Active Directory and Azure Active Directory connectors, right? As you see, so these rules will be used if you need to invoke some kind of PowerShell scripts, that needs to be executed on the Active Directory itself. And similarly, we also have connector after create, after modify, and after delete rules. That's again for the Active Directory, where which supports to invoke some kind of custom PowerShell scripts, on the Active Directory, right? And those PowerShell scripts will be executed on IQ service. And we have JDBC build map. That again, the build map, JDBC build map is be used to alter the aggregation data for a JDBC source. Then we have a JDBC provisioning rule that is to, to enable the provisioning on a JDBC source, right? Similarly, we have SAP build map and web service before operation and after operation rules. So these are used if you need to modify some of the request object specifically for the web service connector, right? So the before operation is if you need to modify something before the operation, before the provisioning operation, and the after operation is if you need to modify something after the operation, right? It could be during the aggregation or it could be during the operation. So again, so all these rules, we can edit straight through the API. So that doesn't need to go through some kind of rule review process. Okay, and these are the APIs that's available for to manage these connector rules. We have similar to transform, we have list rules, which list all the existing rules within the tenant, and we have create a rule and update rule and delete rule, right? And to execute some of these API, the user must be having an org-admin. This is to make sure that only the administrator can perform the action, and they are aware what they are performing. Okay, so the another important task is the rule migration across tenants, right? So let's this is the third use case, and typically, as part of the migration from sandbox to production, right? During the go live, we need to migrate all the configuration from one tenant to another, and so we have APIs available to migrate the transform, the sources from sandbox to prod. Similarly, we need to migrate the rules, right? So again, if it is a connector rule, those connector rules we can leverage a API to migrate from sandbox to prod. But if it is a cloud rule, the cloud rules also needs to be migrated, right? So if the cloud rule exists in one tenant, that also need to be that need not to go through the review process, right? So with that in mind, our engineering has made some recent changes so that we can migrate these cloud rules without review process, right? So the assumption here is there are no changes that will be performed for the cloud rules that's already deployed in the tenant. Okay, so so the connector rule does not need any kind of review, right? Okay, and also the only way we can migrate the cloud rules through API is we need to make sure we are not making any kind of changes between the sandbox and prod. So for that reason, we always recommend to build the cloud rules so that they're not tenant dependent, right? So instead of using the source IDs, better to use some kind of source names. Okay, so let's talk about how this migration works across the tenants. And so we'll be leveraging these export API. And so when we export the rules from one tenant, so what happens is that would be cryptographically signed. And so there will be some kind of hash on that rule, right? So that way, when the same rule is imported into the next tenant, so we can make sure that the hash is not changed, so that the rule is not updated. So that way, it will allow to import that rule in the new tenant. But if the rule is modified for some reason, then the import will fail. So these cloud rules need to go through the review process. Okay. So as I said, once we export the rules, so then there'll be some kind of hash created, and once we import, we kind of validate that hash. And so these are the APIs that's available to migrate configuration from one tenant to another, right? So similar to the creation of the rule, so we have the export configuration, right? So we have this API where we can export the configuration. So this API does support other objects as well. It does support export of the sources, identity profile, rules, and other objects. So like once we export, then there is an API to check the status of the export, and then the other API is to download the exported file itself. Then again, there is a series of API to again import that downloaded exported file, and then check the status of that import, and then we can import the status of the imported data. Again, so to make some of this, to run some of this API, the user need to be an rgadmin. Okay, so let's talk about some of the best practices for this rule. So, you can solve the same problem, right? And for the same problem, there could be some multiple ways to solve it. So there is no one is right or one is wrong, right? So the implementation team need to make the best judgment, and they need to choose which one would be better, right? And again, so when they choose some approach, they need to also keep that into consideration. So the approach they are taking is maintainable, going forward, and it is easy to understand by other team members in the team. Okay. And again, so when we write a rule, we also need to make sure that we account for all the bad data, right? Also the null checks, right? So the data from the source may change, right? So we need to make sure that we have null checks, and also we have account for the bad data. And similar to transform, so it's always recommend to leverage some of the examples that's available in our rule guide, and also leverage the examples from the SailPoint community. Okay. And so for the rules, we always recommend to use the IDE. I personally use Eclipse, but we have a few team members who prefer to use Visual Code, right? So it's always good to use some kind of IDE to develop these rules. And also keep that in mind, the rules in Identity IQ, they're not same as rules in IdentityNow, right? And also the rules in IdentityNow as more restrictive, and then we cannot use the same API that works in Identity IQ and expect the same API to work in IdentityNow, right? So we cannot use something like context to query the data, right? So that is not recommended. Instead, we have this rule util methods developed by our engineering. So we need to leverage that IDN rule util to query the data model. So whereas the connector rules, they are almost similar between IdentityIQ and IdentityNow. Okay, and then we do not have Java doc published for IdentityNow. The reason is, so we encourage everyone to leverage the examples that are available in the rule guide, and then if more assistance is needed, it's better to reach out the professional services team through some kind of expert services ticket. Okay, and so for the rule, when we write a rule, we need to follow this naming convention. Make sure the naming convention of the rule is followed with rule space hyphen and the type of the rule, and then name. Right. If you're writing any kind of generic rule, it has to be again still rule hyphen, and it has to be the type is generic and then name. Right. And we also need to make sure that we convert all those encoding characters with ampersand, less than, greater than, and all those things. And so it's also recommended not to have multiple versions of the rule in a single tenant, right? So we always need to have one single version for one use case. So also our engineering has put together a SAS rule validator script. So before the rule is submitted for the rule review, so we need to make sure that we validate the rule through the SAS rule validator script, and then we need to also submit the output of that validator script, right? And for logging, we need to use the log.info or log.debug, depending on the depth of the logging. And always recommend to use error handling, try catch when you're making an API call, and also need to make sure we always have null checks. Okay, so coming to the again, we have transforms and also we have rules. Both perform almost similar function. So we always recommend to use a transform and use rule only when the same desired result is not achieved through transform, right? So the reason for that is that the transform are easier to view and then edit by the administrator, and they are easy to migrate, right? Because the deployment of the transform need not to go through any kind of rule review process, whereas the rules, all the cloud rules need to go through rule review. And sometimes these like making the rules work, it does take a little bit of time, and then there will be some kind of back and forth between the professional services team and also the implementation team, right? So for example, for the identity attribute rule, so the recommend is to go with identity attribute transform. And for the identity generator, so we need to use identity attribute transform, right? Similarly, for correlation and manager, so we need to use a correlation config and manager config. And for the operation rules, right? If we have a requirement to perform any kind of after operation activities, then it's always better to leverage workflows. So with that, I will pass it on to Christian to go through the next few set of slides.
Hi, thanks, Lex. So I'm just going to summarize just what you've been going through there. Thanks. So using transforms versus rules. So there's a lot of overlap, right? You can use transforms and rules, but as Lex suggested, lean towards transforms because you don't have to go through a process to get it imported into IDN into usage. And the other thing as well is the safe to use, because very low programming experience is needed to actually get a transform, or if any programming experience is needed at all. Both can generate account attributes at provisioning time. Both can calculate identity attributes. So use the best tool for the job. There are some areas that transforms can't be used at the moment, like connector management correlation type rules before provisioning, etc. So, but again, you know, if you can use transforms, I would certainly try and take stock in that. And considering the fact that you've got the static transform type and using stuff like velocity templates can get you a lot of the way forward. So ultimately, I've just done a quick summary of it, of the pros and cons. Ultimately, it comes down to Bean Shell is more powerful, but with great power comes great responsibility. So you're going to have to make sure that when you develop them, they don't blow up in your tenant. So you've got adequate error trapping in place. Use best practices for that. If you don't know what the best practices for Bean Shell for error trapping is, look to Java. How Java works. Bean Shell is essentially an interpretive view of and a simplified views of Java. The other thing about Bean Shell that we need to bear in mind is the performance may vary depending on how you've built it. So if you've done some things and maybe you're not so sure about the APIs or whatever, and you do something inadvertently, you may be affecting performance. So there's an area of expertise which is needed there as well. So if you're not sure, reach out to Compass and ask, and make sure that you get a good answer coming back. Of course, another con on Bean Shell is that you need the rule reviews, which means to take longer to deploy. But Bean Shell rules are quite versatile. And on the flip side, transforms are simple to use. The performance-wise, we've already worked out how the best way to get the performance out of these transforms. There's no review required, so you can just upload it and try it. It's a lot faster because of that, and there's various things that you can try out locally, like velocity templates. You can try those out, and there's some areas where you can actually test them inside an IDN. And saying no development skills are required, I would say little development skills are required. If you're getting into the templating area, you need to understand a little bit more, but it's still a lot simpler than Bean Shell. Saying that, it's not. It's a lot simpler, but it's not as powerful as Bean Shell, so it won't cover all the use cases you're after. And of course, transforms are not available everywhere where rules are. So again, it's a case of balance this out, use the best tools for the job, and yeah, I'll hand it back over to Lax, and he'll do some demonstrations. Hi, Lax.
Yeah, I think we have very little time. So let's see. I quickly wanted to at least show you some of the APIs that's available for Transform. Let me go ahead and share my screen. Okay. Is everyone able to see my screen?
Yeah, I can see it.
Okay. So so for the rules, as I mentioned, we have API that's available, and one is the list the rules, where we can list all the rules, and then we have create rules. In this example, what I have is some kind of delimited bitmap rules, right? As you see, the code has to be, we need to escape out the spaces. So for that, what I do is I use this website, escape of the space. So so this is what the actual code is, right, which we can read. But when we are using the API, we need to make sure that we escape all the spaces, so that it has to be in this format, right? So if I take this code, okay, and then so let's assume we have developed this code through some kind of IDE. When it comes to deployment, we need to make sure we escape it, right? We escape all the spaces. So this is what we need to use, and then as part of the script, right? As you see, we have the type is build map. This is the description of the rule, and this is the name of the rule, and this is the actual the logic of the rule, right? And then make this create API call, so that will go ahead and create. I think I already created this one. So if you need to view again, we can.
Hey, Lex, sorry to interrupt, but we might need to keep going here and move on to the next presenter.
Yeah, sounds good. Yeah, sure. Thank you. Yeah, so that's all I wanted to at least quickly go through the rule API, and it is very friendly to migrate rules from one tenant to another, and also to develop some of these connector rules.